All right, folks, let's talk about problem number 2 that you guys wanted to look at in that worksheet. We're finding the area with known cross-section whose base is this circle, x squared plus y squared equals 4, right? So basically, I've got this idea. I've got an xy plane with a circle that's going to form my base, all right? Where it goes from -2 to +2. Isn't that the radius of the circle, all right? And so this top function, if I put this equation in function form, it would be y equals plus minus square root of 4 minus x squared. So this top function would be y equals positive square root of 4 minus x squared. And this bottom semicircle will be y equals negative square root of 4 minus x squared, right? Okay, so if I want to find the volume created using squares that are stacked on this circular plate, again, the bottom of each square is going to start from this top function and go all the way down to the bottom function. Now, how far is each one of these chords going to be? Well, does it make sense that this length or this distance should equal the top function minus the bottom function, right? Okay? So ultimately, that gives me, I want to go ahead and erase this now. This gives me that the distance across here should equal 2 square root of 4 minus x squared, right? Now that's going to be the side length. Okay, so this is that distance across there, right? Now this is going to be how long each side of my square is going to be, right? And so ultimately in part A, to find the volume, I know the volume of the integral from -2 to +2 of the area of each square times dx, its width, right, which is infinitely thin. And then I'm going to take the sum of all those, right? Well, again, since s squared is the area of a square, since every one of these lengths represents s, right, I know that the volume will simply equal the integral from -2 to +2 of 2 square root of 4 minus x squared dx. And that's how you get the volume formed by squares. Okay? All right, the next shape will be equilateral triangles. All right? So now I'm going to erase this. For equilateral triangles, in example B, instead of doing the area of a triangle of a square, I'm going to do the area of an equilateral triangle. Right? Now again, the formula for an equilateral triangle is equal to radical 3 over 4 times s squared. Right? Now again, what's happening here is the bottom of this length is going all the way across the circle, each one of these chords, will be the side length of each side of the equilateral triangle. So similar to the square, this will be s equals 2 square root of 4 minus x squared. So that volume will simply equal the integral from -2 to +2 of radical 3 over 4 times side squared, which would be 2 radical 4 minus x squared dx. And again, if you want, you can pull this radical 3 over 4 out front of the integral, but since you're doing it calculator, you don't have to. All right? All right, and then lastly, not lastly, the semicircle. Okay, now the semicircle is going to be a little bit different. Okay, so to do the area of a semicircle, right, I'm going to come back in here, and again, I'm going to just re-represent this now. Each chord that I draw in here, each one of these chords, that'll be the bottom of the semicircle. But if you think about that, so I've got a semicircle that's going to look a little like this, where that's the length across the across this bottom, and the semicircle comes in like this, correct? Well, if this is the length across that bottom, that's not the radius. Isn't that the diameter? So my diameter in this case will equal 2 square root of 4 minus x squared. Well, what's the relationship between a diameter and a radius? Isn't a radius is half of the diameter, so it'll be 1/2 of 2 square root of 4 minus x squared, or simply square root of 4 minus x squared. All right? Hey, what you need? Look at that top printer right there. Okay. So the volume then would equal the integral from -2 to +2 of, since it's a semicircle, it's not a full pi r squared, it's 1/2 pi r squared dx. Now, the 1/2 of the pi can come out in front because those are constants. Times the integral from -2 to +2, and the radius we just established is 4 minus x squared. So this would be times 4 minus x squared dx. Okay? For this again, this is my radius. All right? And again, that's what you're gonna do. Now again, this one actually, if you're doing by hand, would be pretty easy because the square and square root cancel out. Okay? And then the last shape that we have is the isosceles right triangle. All right? Or also known as the 45-45-90 right triangle, where again, this will be the hypotenuse. So basically what I'm looking at, and this is, forgive my freehand drawing here, but this chord is the representative of each one of these 45-45-90 right triangles, right? Now again, I know that the formula for this triangle is area equals 1/2 base times height. Well, this is my base and this is my height right here, okay? Well, again, I know that the base has to equal the 2 square root of 4 minus x squared. But what about this height that I don't have? Well, again, because this is an isosceles right triangle, I know that this height will create, this will bisect this bottom side, this hypotenuse, into 2 equal parts. And since that's a 45-degree angle, this has to be a 45-degree angle up here, if that's 90. So I've actually got another smaller 45-45-90 created with this height and this base. Now again, if this whole base is 2 square root of 4 minus x squared, isn't this half a base square root of just 4 minus x squared, right, on each side, like that? And if that's the case, doesn't it mean that this height would also have to be equal to this half a base? So I know that height's going to be square root of 4 minus x squared as well. Right? So now the area formula that I'm going to plug in here, the volume would equal the integral from -2 to +2 of 1/2 base times height dx. So the volume would equal the integral from -2 to +2 of 1/2, and if you want, I should have pulled the 1/2 out in front, but 1/2 of the base was 2 square root of 4 minus x squared, and the height was just the square root of 4 minus x squared. There's my integrand dx. And again, if you wanted to simplify this, I'm going to go ahead and do some simplification here. Wouldn't the volume equal 1/2 times the integral from -2 to +2 of, actually, not 1/2. Wouldn't this 1/2 and that 2 cancel? So wouldn't I get just the integral from -2 to +2 of, well, when I multiply these radicals out, don't I just get 4 minus x squared, because the square and the square root cancel each other out, and that's going to be your volume of the isosceles right triangles. All right? Okay. That's problem number 2.
Hi, Andrea.
Hi, Andrea.
Yo, what up, Andrea? How you doing?